China has just unveiled a groundbreaking AI brain that behaves strikingly like a human mind, yet it runs over 100 times faster than the advanced systems we're used to seeing. Now, here's some context. Most of us are familiar with everyday AI chatbots. But what many people don't realize is that these chatbots act like energy black holes, constantly consuming massive amounts of power. Whether you call it hype or harsh truth, experts are debating just how much damage this could cause. According to a recent analysis published by MIT Technology Review, AI servers in the United States alone consumed somewhere between 53 and 76 terawatt-hours of electricity in 2024. To put that into perspective, that's enough energy to power over 7 million American homes for an entire year. And remember, we're only talking about the US. Here's the wild part. Every single time you ask ChatGPT a basic question, it burns about as much energy as leaving a light bulb on for an hour. Request an AI-generated image? That's the energy equivalent of running a microwave for 15 straight minutes. Now imagine multiplying that by the billions of requests happening worldwide every day. That's where today's story gets fascinating. Because a group of researchers may have finally cracked the code to make AI not just faster, but thousands of times more energy efficient by studying and imitating the way our own brains work. So how does this compare to our own brains? Enter the spiking brain. And trust me, this isn't just another small tweak. This is a complete game changer that could redefine the future of artificial intelligence. Here's the simple version. Think about computers in the 1990s. Bulky machines that would overheat your room and roar like jet engines. Now imagine shrinking all that down into a smartphone that's more powerful yet barely sips any battery. That's what spiking brain is doing for AI. The secret? It operates more like a real human brain rather than a traditional computer. Standard AI models waste power by performing calculations on every single data point, even when most of it is zeros or meaningless. It's like forcing a calculator to constantly figure out what 0 times 0 equals. Completely inefficient. Your brain is much smarter. Neurons only fire when something important happens. If nothing's going on, they stay silent. This event-driven processing is why the human brain can do extraordinary things while running on just about 20 watts of power, less than a household light bulb. The researchers behind spiking brain figured out how to replicate this. Their system only activates when there's something worth processing. They call it spiking because the artificial neurons fire in bursts, just like real ones. But they didn't stop there. They reimagined the architecture itself. Traditional AI relies on quadratic attention, which means the more text you feed it, the exponentially harder it becomes to process, like a conversation where every new word makes it twice as difficult to follow. Spiking brain, instead, uses linear attention. That means whether you give it a short tweet or a full novel, the workload scales smoothly, not explosively. On top of that, they integrated a mixture of experts design. Basically a team of specialists where only the relevant ones step in for each task, while the rest take a break. The results? Stunning. The team built 2 models, Spiking Brain 7B and Spiking Brain 76B. The smaller 7 billion parameter version ran more than 100 times faster on long texts compared to conventional models. And their spiking method reached 69% sparsity, meaning nearly 70% of unnecessary computation was skipped entirely. In real-world terms, that's like your phone battery lasting 69% longer, or your laptop tearing through massive documents at lightning speed. That's the leap forward we're talking about. Here's another fascinating twist to the story. Unlike most AI projects that rely almost exclusively on Nvidia GPUs, the researchers behind Spiking Brain trained their models on MetaX hardware, China's homegrown alternative to Nvidia. And that's huge. Why? Because it proves that cutting-edge AI doesn't have to be locked into one company's hardware monopoly. They successfully trained their massive 76 billion parameter model on hundreds of MetaX GPUs for weeks, without a single crash or stability issue. The smaller 7B version reached a 23.4% model flops utilization rate, which in engineering terms translates to seriously impressive efficiency. Even more remarkable, they accomplished all this using only about 2% of the training data that traditional models typically require. But spiking brain isn't just a cool standalone experiment. It's part of a much larger movement known as neuromorphic computing. The belief that the future of AI lies in mimicking biology instead of just throwing endless raw computational power at problems. And this isn't a fringe idea anymore. This year alone, we've seen major momentum. Cornell Tech teamed up with BrainChip to launch courses in neuromorphic computing. Purdue University secured $32 million in funding to design brain-inspired computing systems. Meanwhile, tech giants like Intel and IBM are investing heavily in chips built to function more like biological brains.
Today's large AI models have scaled beyond 1 trillion parameters. The New York Times reported that AI could soon need as much electricity as an entire country. These trends highlight the need for fundamentally new approaches to AI. At Intel, we are exploring a hyper-efficient solution inspired by the brain called neuromorphic computing. Brains use very little energy, yet can solve complex problems while learning in real time. Unlike today's AI systems, the brain relies on sparse and adaptable networks of neurons. By computing only when and where it needs to, brains achieve greater efficiency and faster response times. These brain-inspired networks have been implemented in Intel's latest neuromorphic research chip, Loihi 2. In labs around the world, Loihi has demonstrated orders of magnitude gains in power performance over traditional processors.
As one researcher from AOSS recently explained, the way we're building AI today simply isn't sustainable. We're already seeing staggering levels of energy, water, and land consumption, and it's only going to get worse. The International Energy Agency projects that global data center electricity demand could more than double within just a few years. Right now, data centers alone already consume around 1.5% of the world's total electricity. Some companies are even making extreme moves to feed this energy appetite. Elon Musk's AI training hub in Memphis was found supplementing the grid with dozens of methane gas generators, potentially skirting the Clean Air Act. Meanwhile, Microsoft is exploring the idea of bringing nuclear reactors back online just to keep its AI servers running. This is exactly why brain-inspired systems like spiking brain aren't just fascinating, they're critical. Nature spent billions of years perfecting the human brain for maximum efficiency, and for the first time, we're beginning to copy those designs instead of brute forcing our way through problems. Here's the best part. Spiking brain proves you don't need to sacrifice performance for efficiency. Their models matched or even came close to the results of much larger power-hungry systems, while consuming just a fraction of the energy and training data. The 7B model, for example, recovered nearly 90% of its base model's performance, performing at levels comparable to other advanced systems. The team even tested a lightweight 1B parameter version on mobile CPUs, and the speed gains were astonishing. In practice, this means your smartphone could eventually run AI that today requires sprawling data centers. Think about that for a second. Right now, using AI means renting time on enormous, energy-guzzling servers scattered across the globe. But with technology like spiking brain, we could see a future where your own devices handle advanced AI locally. No constant internet connection required, and with almost no drain on your battery. Imagine chatting with an AI assistant as capable as GPT-4,